I am Chris Hein. I'm a partner solutions architect here at AWS. Well, not here, but at AWS. And I pretty much spend all of my time in the container ecosystem, specifically with Kubernetes. And as Andy said, I talk to a lot of customers in this space, as well as a lot of partners. So companies like Aquasec or Security. And today we're going to be talking about operations after deployment. So this is really, as Andy was saying, the life after you kind of go through and secure your cluster. So show of hands, who's actually running, or if you dare, who's running a security solution currently that's scanning your images? Cool. Okay. How about that's running against your running clusters? That's in your cluster. All right. Hopefully we can change that. All of those hands. So first off, what is a secure Kubernetes cluster? And this is really going to be mostly a little bit of a waste of your time because you've seen so many presentations that have gone through all of this content. So I only have 3 that are just going to brief over it. First and foremost, here are the key things that I like to think about when I talk to customers around a secure Kubernetes cluster. We're going to first start with least privilege. And this is one of those ones that's incredibly difficult, if I'm being completely honest, because most of the time this ends up being a very manual process. Then we're going to talk about automated controls and continuous feedback. So as I was saying, this one is really probably the most difficult one out there because it is mostly a manual process, knowing what your applications actually need access to and making sure that those aren't accessing extra resources. There are tools out there to help with this process. There's a QR code to audit to RBAC, which will be very beneficial to you. But these are the key components that you should be implementing in all of your clusters. Make sure your clusters have RBAC turned on. Don't run a cluster with ABAC anymore. We should be done with that by now. Actually, show of hands, who still has ABAC? Good. Nobody has ABAC. Thank you. You should constantly be auditing your roles. So this is going through and actually checking what those things have access to. There's a bunch of tools in this space. I work heavily in the open source world, and there's a bunch there. Don't reinvent the wheel. We already have done this a bunch of times, so please go check those things out. The audit to RBAC is one that will really be beneficial. It uses your audit logs and basically checks what applications are accessing and gives you a role that you should be able that you can apply to your cluster for a specific application. And then the last one is use an identity provider. Everybody in here pretty much, I'm guessing, is mostly running Kubernetes at this point. And you know out of the box there is nothing there except for some certificates, which is fun to play with if you really want to. But use a real IDP. Use anything else. Use a SAML login. Use IAM from AWS. Whatever works for you, whatever your users are actually all based on top of. For example, in EKS, we use the AWS IAM Authenticator. It uses IAM roles to allow you to associate a user with a Kubernetes cluster. All it is behind the scenes is a whitelist config map that you deploy into your cluster. When a request comes through, we check to see what user made the request. Is it in the whitelist? We pass it off to Kubernetes RBAC, and you don't have anything else. Who's running EKS? A show of hands. Cool. Who's running on Kubernetes but running like BYOL or BYOK8s on AWS, on EC2? Awesome. All right. So again, these are going to be really basic because you already know these and you've listened to everybody tell you about these things before. Next one we're going to talk about, automated controls. Out of the box, you can use all of these things. Network policy, you do need to implement something else, but use pod security policies. These are going to help you just by setting some base ground rules. Your developers don't need to think about it, or all of the developers in the group, because there was a lot of hands there, which I'm pretty impressed by. And I hope you like the rest of the talk, because this is mostly a call out to the security people to help you later when security events happen, because sometimes they hand that off, and that's a pain. But anyways, continuing forward, use pod security policies. Just implement these. Even at the most basic level, just go through and check out the same defaults that the Kubernetes docs has, and try deploying those. See what happens. See what breaks. Most likely, you're going to find some root containers. Again, as everybody said, don't run root. Network policies. This is a huge one. Out of the box, for example, with EKS, we don't actually do anything for this, so this is something that you need to implement yourself. So make sure you're knowing what's going on there and being able to actually put something in place to help you out here. So something like Calico, that you could write a network policy controller or a network policy manifest file, and you could go forward, and that pod now doesn't have access to whatever resources you don't want it to. Very simple. This is something that you should be doing out of the box. Cool. Last one is don't run in root. Just don't do it. And then we're moving on to continuous feedback. So here we're actually talking about the more automated controls, but this is things that you really need to implement on top of your clusters or whatever your processes you use. So scan your environments. So in this instance, have something in place in your cluster. Run a tool like Aqua Security, run a tool like Twistlock, any of the vendors out there that do all these things, because they're incredibly helpful. They will actually start the process for what we're going to be talking about next. If you don't have these in place, you're not going to be in a good place to start doing your remediation. You're just not. You're not going to know what a baseline is. You're not going to know how to actually go through and solve for the problems that you're going to run into. You might not even recognize or see these problems coming through. Next one, scan your images. So again, I only saw that a few hands that were actually scanning the images. This is something you should be doing. Everybody's already beaten this, in my opinion, but just continue to do it, or go do it. Go implement it. If you don't want to pay for it, go use Claire. Go use anything out there that will do this and help you get moving forward, even at the most basic level. It's very, very important. And then last thing, implement these in your CI/CD process so that developers know. Everybody that's a developer in here, would you rather be told about a security issue after it's in production, or would you rather know ahead of time? I'm actually asking a question. I want to hear people talk because it's late in the day. You want to know after? You want to know after it's been deployed? Okay.
It doesn't alter my ship date, because I got to ship now.
That's a very good point. Maybe you shouldn't have that ship date then. Maybe you should have a fluid ship date or ship date. Say that one more time.
We have a very sophisticated red team. Best way is to attack because otherwise you have scanning signal noise ratio that creates an 80.
All right, I would disagree completely with that. All right. Well, you could still have that red team. Just having this up front actually stops a lot of those really minuscule things getting into production. So anyways, now that you have a secure cluster, because that's what everybody in here has now, right? We all have secure clusters, and everything's great and fine and dandy. So what actually, again, just to refresh, this basically means that you went through and you set least privilege. You're not deploying a user that has cluster admin and your service account, and you're just granting full access. Let's think about Tiller in this place. How about that? And you have automated controls. You've implemented pod security policies and network policies, and everything looks great. And you have the continuous feedback. You have the defender running somewhere, and that's actually scanning all of the running images and all of your scanned images, and everything feels wonderful. And this is what it gives you. This is what your guys' life is like, right? This is what everybody's life in here is like now. Developers can contribute code as much as they want. They can feel comfortable with it. They can own that code all the way to production. They get a little notification on their pull request when something fails. It feels wonderful and fine and dandy. And your CI/CD is backing all of those deployments, and you have full auditability. Now everybody knows who screwed up production. I love it. It's wonderful. But reality eventually will set in, and some things slip through the cracks. Now what do you do? So this is really the core of the NIST framework. If you're not familiar with this, this is online. I don't have a link. I should have put a QR code in here for you. But this is the basics of the NIST framework. You're going to go through multiple steps, and you're going to actually start solving the problems that you let through into production because of that small little crack. Don't worry, though. You already have a secure Kubernetes cluster, so some things are still protected. But the first thing that you're going to do is you're going to go through, and you're going to identify. And we'll dive a little bit deeper into this Then we're going to go into protecting. What do you do next? After you've identified. And most of these things, or actually the first 3 of these things, are really easy to implement. And in fact, those of you that raised your hand about scanning images and scanning your running containers, you're already doing this. And then we're going to talk about how to respond to those events and how to recover from them, because things happen. And you have to know what you're going to do and plan for these things, because as much as we want to prepare and say that it's not going to happen, there's going to be something that happens. So, identify. Like I said, you're all doing this already, or those of you that raised your hands. This is going and actually implementing a solution that's going to sit there and allow you to set a baseline. Because right now, you don't know anything about your applications, or those of you that didn't raise your hands don't know anything about your applications. You might think you do, but you don't know all of the calls that are going on. You don't know all the syscalls. You don't know everything that it's requesting out to, and you should. So implement these tools so that you can actually set a baseline. These tools should have machine learning behind the scenes that's actually going through and normalizing that data and figuring out what that baseline of resources that it should be reaching out to are. And then you should be taking everything that you're learning here today and taking this back to the rest of your teams, because they will benefit from this. Because you absolutely, if you don't have buy-in from the rest of your teams, it's just going to be all on your head. And you're going to be the one implementing that. And that's not fun. I know I've definitely done that. Been like, oh, this is going to be great. I know what I'm doing. Not going to tell anybody about it. I'm just going to do it. And then, oh, wait, now everything relies on just me being there. And that falls apart really quickly. So take all this stuff back and talk about the attack vectors, talk about container isolation, talk about network security, talk about host access, all with your teams. Go back and make sure that you're educating everybody so that everybody's all on board. Now that you have these tools and you've thought about these tools and you've implemented them, you're starting to set a baseline. What I was talking about before, those machine learning based tools that are going to go through and pay attention to all the syscalls that are going on, pay attention to all the network calls, and create that model for your application, that machine learning model for your application. Now you can basically be assured that if something goes out of those bounds, that anomaly, you're going to be able to catch it. And you should be doing this with all of your apps in production. Don't just do this on a staging server, because it's not getting real traffic. Unless you are implementing something that replays that, then that could work. But if you're not, because a lot of companies that I've worked with aren't, do this in your apps in production. And build those models and get them into a place where you feel comfortable. You'll be able to go through and pay attention to what's in those images, what's going on at the application level. And the team should then know and feel comfortable with it and scan these things on a weekly basis. If not bi-weekly, what have you. You should just be paying attention to these and looking at what's actually going in there and being able to see if maybe there isn't something that's being caught by those systems. Then, we're going to be implementing detect. Now again, like I said, the first 3 that I've already talked about are all implemented in most of the tools that you will deploy. This could be, this is something as simple as sending an SQS note or an SNS notification, sending a chat message to whatever chat client you use, sending text messages to people, whatever it is that's really annoying that gets people paying attention to what's going on, because these are important events, right? That CVE that everybody's been talking about, that was really important, right? 9.8 score. We should have been notified about that immediately and start fixing that. So these alerts that we'll get, we should be setting them based on the baseline, implemented using those same exact tools. And then we're going to move into the actual remediation. So what do people think is the first thing you're going to want to do when something happens, when, say, a container is compromised? Snapshot. Okay. Anything else? Isolate. Cool. I like that. All right. These are the 4 that I put on here. So first, cordon the node, because you don't know how far they went. For example, what was it last year? There was the CVE around subpath host mounts. You don't know if they actually got root access to your whole node. So cordon your image. Take that completely out. I also then have isolate your node's network. So around that node that you actually just ripped out, change the security groups. Make it so that nobody has access to it. Next thing I have in here is pausing the container. I actually don't have snapshotting on here, but pause the container. Because guess what? Pausing the container stops the resources from being used. And now that Bitcoin miner that everybody likes to talk about isn't running anymore and not using all of your resources. And then the last thing you're going to be doing in responding is analyzing the logs and processes. So this is going in and actually checking to see what those Docker images were running, what your actual node was running, see if anything got pushed down into that level, and really, really diving deep at this level. The next thing is going to be remediate, or recover at least. So first thing you're going to want to do is obviously get to the root cause, because you're not going to want to just restart the image. You'll see a lot of people that will be just like, well, if you restart it, then they're not a part of it. But that's really just a temporary fix. Go through, and this should be extremely basic. Everybody should know this. Go and understand the root cause. Patch the vulnerability, like Kubernetes core did with that CVE last week. Just go patch it. And then, using a CI/CD pipeline, roll out the change. I've seen this a lot, where companies just skip out on the whole thing. They're like, we just need to push it to production. Just go. It just doesn't matter. Just get it out there. And it doesn't work that way. We already put these things in place, and they should be fast enough where it doesn't matter if you're going to do that. That 2-minute delay isn't going to hurt you when you're actually going through and actually checking to see if it really solved the issues. Because your scanning technology should actually be checking to see if those things are working. So this is pretty much for most of what my talk is going to be about. So what did we learn? Kubernetes doesn't solve all your problems. It's not going to do that. It's going to get close, but it's not going to solve all your problems. I'm just going to tell you that. It's not going to solve all your problems, I promise. I want it to, but it's not going to. Use open source and commercial products to solve some of these things. There are a ton out there. You can search GitHub and you will find tons of great tools. Aqua has a bunch of them. It's fantastic. And then, as AWS always says, security is day zero, and you should be treating your security this way too. So really, really start thinking about it that way. That's pretty much my talk. Anybody have any questions?
All right, great. No, great job, Chris. Thank you. We can open it up to a couple questions. Anybody questions for Chris? All right.
I mean, in most cases, if you're compromised, by the time you know, it's way more complicated than just isolating the node. The real adversaries have already had tentacles throughout your whole system. The fact that they got in, most likely they're way further than you are, where you think they are. So I mean, that's great, but like the truth of the matter is like an Equifax, 4 months in, and most breaches are. I think the average zero day, I think, is 30 days in the industry by the Sonatype supply chain report and the Verizon report. It's on average, most people do not even know they're breached until 30 days. Anyway, so it's way more complicated than just like shutting down a container or pausing container.
It's a comment, and maybe not,
But see, the thing that you have to remember here is you need to instill these things up front, and that's the real call out, is making sure that you're doing it up front, because if you're not doing it up front, you are potentially in that same exact scenario where you don't know about that. But if you're actually setting baselines and you have something that's sitting there and scanning, you will have a better chance. I can't guarantee that you're going to know, but you will have a better chance of catching that one thing that is weird that just happened. So.
All right, great. One last question? All right, thank you, Chris.
Cool.